Hi, good afternoon. Welcome to the Amazon Neptune Deep Dive. Appreciate the great turnout and everybody interested in graphs in Amazon Neptune. Before we start off, I wanted to introduce some of my co-presenters. I'm Brad Beebe. I run Amazon Neptune. Also joining me today is Karthik Bharathi. He leads product for Neptune. And Aurel Asla, who's a graph technologist with us. How many of you are using a graph database today? Raise your hand. OK, cool. How many want to use a graph database? But are? Great. How many of you are using Property Graph? Tinkerpop Gremlin? OK. How many of you are using RDF? A few? OK. I'm interested in what the people who were using a graph database but didn't raise their hands here are using. But we could follow up afterwards. How many of you are using Amazon Neptune? Fantastic. If you're interested in Neptune, we do have some other sessions that show how customers are using Neptune and building applications for things like identity resolution, NBC Universals managing their content catalog. Uber's giving a talk on Thursday about high-fidelity map versioning using graphs. So lots of opportunities there if you're interested in learning more while you're here at reInvent. Graphs are everywhere. Graphs are a data structure that consists of nodes and links, and they're particularly well suited for representing and describing relationships. This picture is a graph of global air routes from a book that we'll talk about in a little bit. But it's just one of many examples of applications and use cases that you can solve with a graph. There's lots of things that you might think about, things like social networks, things like fraud, things like knowledge graphs. But there's many that you might not think about in terms of life sciences, finding new treatments for approved drugs. And there's even things that, as developers, we haven't really conceived of using a graph for because we're still thinking about relational databases or key value stores, and we're really not yet thinking about relationships and making them first-class citizens. And the things that all of these graph applications have in common are the relationships. You know, customers ask us, when should I use a graph database? And the answer is, when you have relationships, and the primary thing that you want your application to do is to ask questions over them. So you want to issue graph traversals or graph patterns. If you look at the customers that are using Neptune, you'll see that diversity of use cases reflected. Knowledge graphs, security endpoint detection, content management, gaming, many others. So graphs are a data model that represent relationships effectively, and they show up in many different places. And so I would challenge you guys as developers to think about, if you take a relationship-first perspective, what new challenges can you solve and what new applications can you build? I'm going to introduce Aurel Asla to talk briefly about some of the graph models and frameworks.
Thank you. So we basically support two different kinds of graphs. And this is kind of where it gets a little tricky, or at least people think it gets tricky. So first of all, we support property graphs. And it's a kind of a common name for types of graph that many graph databases support. In our case, we support the Apache Tinkerpop API and the Gremlin traversal language. Some people say query language. I sort of tend to think of it as a scripting language for traversing graphs. And a number of open source projects and vendors support this API and the language. But we also support RDF, the resource description framework. And this is really, at the moment, the only industry standard for graphs. It's heavily standardized by W3C, the World Wide Web Consortium, for about 20 years now. And for RDF, we support the Sparkle query language. Now, this is a declarative query language, and probably something for those of you who've done relational databases should be pretty. You should be pretty comfortable with it and easy to learn. Now, the question is, how do property graphs and RDF graphs differ? And I would say not very much. The way I sort of think about it, property graphs have data on the edges, RDF not so much. So that leads to slight differences in how you write your models. And we have sessions in this conference about how to actually do the graph modeling, so I'm not gonna touch on that. Some of the other things that RDF supports very well is basically integration of multiple data sources. So if your use case is something where you have, let's say, external data sources, RDF might be the answer for you. And there are a number of, in fact, a very large number of public data sets available in RDF format, including Wikidata, which is basically kind of a data version of Wikipedia, and a number of other data sets. So why do we support both of these? I think many of our customers want both. They don't want to choose. So, and I'll hand back to Brad for some architecture talk.
So to follow up on Aura's comments on graph models, when we talk to customers, what we hear is they really want to build graph. And sometimes a property graph model makes the most sense if you're building an application, and other times an RDF makes the most sense. And so Neptune supports both of these as first-class citizens. Each Neptune cluster that you provision provides both a Gremlin REST endpoint and WebSocket server, as well as a REST endpoint that implements the Sparkle 1.1 protocol. But the heart of Neptune is this blue rectangle. It's a purpose-built storage engine that's optimized for graph traversals and is durable and ACID and provides immediate consistency. It rides on top of a cloud-native storage service that was originally developed for other databases at AWS, and that Neptune is using for durability, read replication, and its enterprise features. In addition to the open source and standard graph models, we also support other interfaces that are really useful for managing your database or building applications with your graph. And these include things like a fast parallel bulk load. So we have a REST API where you can post JSON documents that describe S3 buckets, IAM credentials, load formats, and do a fast non-transactional load into the system. We also have services for exposing query lifecycle management. What are the queries are running? Show me how long they've been running. And we'll talk a little bit later about some new services that we just recently launched to help you do things like integrate with text search, provide change data capture. The Neptune storage service provides a scale-out model for storage on Neptune. Each Neptune cluster consists of a single view of the storage service that grows in 10 gigabyte chunks, which are distributed automatically 6 times across 3 availability zones. The storage service, which is not something that you as a user have to manage, automatically does things like replaces failed storage nodes, takes backups and snapshots. Today, the storage segments can grow to a size of up to 64 terabytes. And in our testing, that translates into a graph of somewhere between 100 billion and 200 billion nodes, edges, and properties, or triples in the RDF sense. The other thing that the storage service provides for us is high availability and read replication. So in this cluster of Neptune that you have, one of the instances is in the role of a write master. Up to 15 different instances are in the role of a read replica. Each instance has a shared view of your graph data, but independently evaluates the queries. As you make updates on the write master, once those updates are acknowledged by the storage service by 4 of the 6 different nodes, the commit point in the storage layer rolls forward. And at that point, that's where the read replicas can now read from. And there can be a replication lag between the write master and the read replicas, and this is typically in the tens of milliseconds. It is a CloudWatch metric that you can monitor and instrument for your cluster. If you have a situation where the write master is no longer available, a hardware failure or something else, and you have a read replica, the service will automatically promote that read replica into the role of the write master, and you can continue operating. If you do not have any read replicas, then the service will provision a new host instance for you, and you can still continue to operate, although this takes longer. So if you have a use case for which high availability is really important, then we recommend that you have at least one read replica, and that you also send some traffic to it to keep the pages that it's using to evaluate queries warm in memory. One of the things that customers often use to learn about graphs is a book called The Practical Guide to Gremlin, which is actually written by one of our AWS principal data architects. And it uses error routes, in fact, the image that you saw at the very beginning, to help you learn how to write graph queries and build graph applications. I think most of us probably traveled here to reInvent on a plane, and so error routes are something that's familiar. In this case, this is a small example graph, and we're going to go through some other examples in the next slide. But there's a couple of things to note about it. The circles here represent nodes. The lines represent what we call a directed edge. The lines connect the nodes together, and there's also properties. So these things have airport codes, and in this case, these are IATA airport codes. And we're going to look at answering the question, how do we find all the airport codes for airports that are one stop between Seattle and Frankfurt? And you can probably guess this example was written by one of the German members of our service team. So look briefly at the graph. You'll see, again, the circles, the vertices, and in particular, you'll see that the identifiers for the nodes are integers. In this case, it means something in this specific graph application. And now if we look at the Gremlin traversal, which is on your left, and we step through it, we'll see we start with a g.v. And this basically says, get me the graph in Gremlin. The first thing we do is we find nodes or vertices that have the airport code for Seattle. Then, in the traversal, we go out, following edges that have a label of route. And you'll see this as statement in the middle that stores off this intermediate result in a variable that we'll refer to later. From that collection of intermediate nodes, we then take another step out in the graph to find routes from them that terminate in a node that have the code for Frankfurt. In the last 2 steps of this traversal, we retrieve the intermediate results, and we print out the values for the codes. And that's how Gremlin would evaluate this question using an imperative traversal model. Now, regardless of whether you're using property graph or RDF, Neptune, inside of that storage service, lays out your data in something that we call quads format. So each element of your graph is represented in some form of a subject, predicate, object, and a graph. And those four things make up the quad representation. Now, as a developer, this isn't something that you normally have to worry about or understand, but as people interested in a deep dive, it's really valuable to you, particularly as you go through more advanced query tuning and query optimization, which we'll provide some reference for later. So if you look just across the top line, you'll see the subject 22 is an identifier. That's the identifier for the nodes. We have a predicate, which is the property value, the property type code. In this case, it has a value, Seattle. And the graph is really unused in this particular case, so we have a default value. If you look down to the second line, you'll see that we're actually encoding an edge relationship. And you know that for two reasons. The first is that the subject is an identifier, a particular node. We have a predicate, which in this case is actually the edge label. And we have an object. And the value for the object is also the identifier for a node. In the fourth column here, we then have an edge ID. And that's how in Neptune, for property graphs, we can distinguish between a property on a vertex and a property on a node. Now, let's look at the same question, but in Sparkle. So immediately, you'll notice these things that look like URLs across the top. These are actually called internationalized resource identifiers, or IRIs. And they're part of the RDF data model that's really focused on interoperability and being able to describe resources across the web. And if you look at the graph model here, you'll see that rather than using an integer, which is something that means something specifically to an application, these are actually IRIs. In this case, the IRI is formed by combining the prefix with the airport code. So there's something that can be resolved outside of the system. Now, if we move down and take a look at the Sparkle query, you can see that Sparkle is a declarative graph query language. So it looks a little bit more like SQL from that regards. We have a select statement. We have a variable, the via code, that we're going to be returning as part of the select statement. And then we match what in RDF is called a triple pattern. So we express these triple patterns to match the graph. The first line says, find the airport Seattle with a property edge route and bind those results to a variable called via. In Sparkle, the question mark with the name indicates a variable. You'll see that variable is then shared across these other triple patterns. And that's how we execute these joins in Sparkle. So we then bind that to where there's a property code. We store that code, which we'll return later. And in the last statement, we then take that variable and traverse out to Frankfurt. And that's how we would answer this question using a Sparkle query over effectively the same graph. As I mentioned, we use the same supporting data model, but this is how it looks from an RDF perspective. There's a couple of things to note here. I mentioned the URIs and the prefixes, and you can see those very clearly coming through in the subject columns. But let's look a little bit about the next line down, so the third line in the table. Here, we're representing an edge relationship. So it starts with a URI. There's a predicate value edge route. And it ends with an airport value, in this case, Hinata. In RDF, there's really not, per se, the concept of edge properties that there are in property graph. Rather, RDF views edge properties as rather additional edges. And there's several different techniques that you can use to model edge properties. So for example, in this routes model, you might want to associate the distance in kilometers with the route between airports. That could be really valuable. And in this case, the way we've modeled that is in the 4th position on the graph, much like in a property graph where we had the edge ID, we're using a specific URI to refer to that. And that allows us, in this model, to represent those kinds of edge properties that you may want to use. Whether you're using property graph or RDF, there's a couple of different indices that Neptune automatically builds for you when you load your data. And these indices are used in evaluating queries, and they help us to quickly and effectively allow you to navigate your graph. And there's 3 in particular. The first is called the SPOG index, or the SPOG. This index uses a key of subject predicate object and graph. And so when you ask questions or queries that start with a subject and a predicate bound, you effectively get an index lookup against the database. Find me all the airports from Seattle, for example. The second index is the POGS, or the POGS index. As the name suggests, this is predicate object graph and subject. And this gives you efficient access when you want to look up, for example, a particular property label or property type and a property value. Find me airports with the code Frankfurt. Then the third index that we maintain is the GPSO index, or the GPSO, the graph predicate subject object. And this allows you efficient lookup when you have an edge ID or a graph and an edge label bound. So these are the indices that we maintain over the quads data model that we use within Neptune to evaluate queries. Now, why do they really matter? Well, they start to matter when you understand and you want to understand your query performance. How can I look at something differently? How can I adjust my graph model? And so in the past year, we've released a couple of different new features and services that are designed specifically to help you build graph applications and fine-tune them. So the first is a Gremlin explain. And the link to the documentation is here for your reference. But it allows you to expose query plans that are specific to Neptune. So this is beyond what you could get from a Gremlin profile step. And you can look at those and understand how you might be able to adjust your query to make it run better. We also have a very similar feature for Sparkle. Sparkle query plans are exposed, and you have a REST interface to access them. There's both the link to the documentation as well as a blog post that we published recently. So I'm now going to hand it over to Karthik, who's going to go through some of the product updates and new features that we've launched.
Thank you, Brad. First of all, before we get into the themes, I wanted to thank you all, customers, partners, developers, and advocates of both Neptune and graph databases in general. Many of the feedback that you've provided us and the feature asks that you've made have rolled into the product. And we continue to do so. And I really thank you for all the features that you've been giving us. So when we look at the capabilities, they really fall under 3 categories. In developer experience, we want to make sure that customers can build graph applications easily, right? And what this means is really you have the necessary tools and capabilities to query your graph, to visualize your graph, to understand how a query is being executed under the hood, or to integrate with other services that AWS provides. In essence, the goal of developer experience is to make sure that you start with an idea and you go to a production application that uses a graph database, Neptune, in the shortest amount of time possible with like minimal learning curve. In the performance category, when we look at our customer base, the set of use cases that they use Neptune for, and the set of queries they use for those use cases, that forms a large data set, right? We want to make sure that Neptune is really good at solving the sort of the interactive / OLTP queries, and it's really performant in that category. At the same time, we want to make sure that we also understand the broader set of query patterns that our customers are using, and how can Neptune be efficient in running that query. Let's say that's the OLAP category. Right? When you look at enterprise features, Brad talked about the cloud-native shared storage service. We want to make sure that you as customers take advantage of all the capabilities that the underlying storage has to offer. For example, database cloning. Can we do a copy on write, so you take advantage of the storage layer and offer that as a capability in Neptune? Can you have multiple read replicas? We said that there are 15 read replicas. So how can you leverage the shared storage layer in order to offer an enterprise-grade service? And finally, in the third category, compliance and regional expansion are areas that we continue to invest on. These are regulations and areas that customers want to run their Neptune cluster in. And we want to make sure that we have the right set when we offer Neptune. So going back, we announced general availability of Neptune roughly 18 months ago. And it's been a tremendous journey. We started with somewhere around 4 regions, and right now we have 16 regions, which includes 14 commercial regions and 2 GovCloud regions in the US. And we continue to expand on a monthly basis. The other capability in terms of security that we offer is encryption at rest. You can use AWS Key Management Service to encrypt your data, so it's secure. And we also offer encryption in transit using TLS. In addition to this, the compliance side, we offer HIPAA, ISO, PCI DSS, and SOC 1, 2, and 3. And we are also looking at FedRAMP, both medium and high, in the coming year. And that's important for some of our customers. Now, this is a quick snapshot of some of the features that we released in the last 3 to 6 months. It's a growing list, but these are the ones that we think we'll talk about today. Off the list, as we go into many of these features, the one that I'll call out is database cloning, right? It is, like I called out earlier, an enterprise-grade feature. It's based on a copy on write semantics, so you're not immediately allocating storage. So you can take a clone of your existing cluster and restore it for, let's say you want to have a backup of your production data, or you want to try out the latest version of Neptune, but you don't want to impact your production cluster. And once you find that stable enough, then you go upgrade your production cluster. There are various use cases of database cloning that you could use. Now, among these, let's pick a few examples. The first one that comes to mind is Neptune supports Sparkle 1.1 federated query. What this means is you take your query and you partition your query across multiple Neptune clusters, if they support 1.1 federated query, or you could have a query to an external data source, like let's say Wikidata, that also supports the same protocol. A good use case would be where you have partitioned your data across multiple clusters, and we do have customers who do that. In this case, where you can have a single Neptune cluster, federate the query across the multiple other clusters, and aggregate the results and return it back to the user. That's a pretty common use case. And you do have the choice of using IAM authentication that's provided with Neptune, and that's supported with federated query as well. the second feature that I talk about, and one of my favorites, is Neptune Streams. Streams is really a change log of the set of activities that happen in your graph database. Folks from the relational database may instantly recognize with a change data capture or a CDC. It's very similar, where you get the change logs of your actions sort of in a JSON object. One of those yellow boxes have been blown up to show you the format of that JSON data. And you can use that for both Gremlin and for Sparkle. And what it provides you is sort of using those streams to do, let's say, a copied scenario where you want a copy of your Neptune database in one region, also available in another region. That's a use case for streams. You can also use streams for a trigger kind of a scenario where any change in your graph database, let's say a new user got added to your social network, and you want to send them a welcome email, that trigger can be done through a Lambda, and that's possible with Neptune Streams today. You could also use it to integrate with other services, and there's an example that I'll talk about in the next few slides. Here's a blog post that one of our architects wrote. It's available in the AWS database blog site. What it does is essentially use Lambdas to trigger a sort of a workload that dumps data into Neptune, which in turn generates streams. And streams, I should call out, is in lab mode, so you need to enable a cluster parameter group parameter to enable streams. And once that's done, you have a change log that's available for about 7 days. So in this case, once those change logs are available, you can have that in a Lambda, and the example talks about doing a statistics operation that's made available in Elastic Cache. It's a very common use case that we also hear from our customers. Now, let's put all of these together and make something more interesting, right? And that's our integration with Elasticsearch. You probably saw the release coming out in the last few weeks. What it does is leverage the purpose-built capabilities of Elasticsearch, which is good at managing your text search on your data set using text indices, and leverage that capabilities in your Neptune queries. So you can use your existing cluster, or you can create your new new Elasticsearch cluster, and have those be federated from Neptune. So we talked about federations. This is a good example for federation. We also talked about streams. This is also a good example of streams, which ensures that all of your Neptune data is available in Elasticsearch if, let's say, you're searching a text log, a server log, and you have those patterns, query patterns available. You can use fuzzy search, query string, prefix, some of the query patterns that Elasticsearch already supports. And you can use that for both Gremlin and for Sparkle. And here's a syntax, just going into the details of the syntax. On Sparkle, we support the service keyword, which is defined by the standard. But there's an extension on specifying the Elasticsearch endpoint. In a similar fashion, for Gremlin, we have an extension with side effect, and you specify the Elasticsearch endpoint and also the query that you want to run. Here's another good resource. These are samples that are available in GitHub. They let you set up a flow where you have data coming in from Neptune Streams, flowing into Elasticsearch, and you can run queries in Neptune that actually access Elasticsearch. Before we go into the next set of features, I do want to show a quick demo on how this all works. So what I have here is a Neptune cluster. I have set up a cluster that's running the latest version of Neptune. I also have set up an Elasticsearch service. In this case, I've created a new one. There is a domain that I created. And what I did was I used the tools that I showcased earlier to connect the two together. And what I'm going to do now is use a notebook to query both these services and show the integration. So as a first step, let's run the status command. For folks familiar with the Neptune curl command, where you give the server URI and say /status, and it shows you, hey, your server's up and running and what version and whatnot. This is sort of a handy keyword, and I'll talk about this in the next few slides. It shows that I'm running Neptune, the version, Tinkerpop, Sparkle. And what I'm also going to do before I show you the integrated version, I have a bash command that essentially talks to my Elasticsearch cluster, and these are standard Elasticsearch commands. I do cat on the indices, and it should show me like, hey, how many indices are present, what sort of data, and the size and whatnot. I have about 500 million rows, a few gigabytes in size, and I'm going to use the Amazon Neptune index in Elasticsearch. I can run a few more. I can run a count on the data set. I can also query Elasticsearch directly because the two data sets are integrated before I go into the Neptune version. Just searching for space. And the data set I'm using here is a movie database, so it contains movies and actors, all linked in a graph. But in the Neptune Elasticsearch side, it gives me a pretty format of all patterns that match space. So you can see that in the value. So it will include people with names having space, movies that have space, and I try to limit the queries to 100 just for practicality. Right? All good. Now I'm going to move to Gremlin side of things. You could use Sparkle too. My cluster is running, all good there. And I'm going to use the with side effect that I called out earlier. I'm going to specify the full text search endpoint. In this case, that's my Elasticsearch cluster, the Amazon Elasticsearch service. And I'm going to do the same query saying the FTS query is going to be space star, right? And this is talking across two services using federation and streams that we looked at. Again, we have about 185. It's a paginated query, so you can see that I'm just bringing out just the name property from my query results, and you can iterate through and view all of the results. Another example here, instead of using a pattern that says starts with space star, I'm using a fuzzy search, inception. I didn't know the spelling. I just typed in a keyword, but I gave in a hint saying that, can you do a fuzzy search? And I believe the default is it tries to add or replace one character and tries to figure out the patterns in Elasticsearch that match inceptions. Run the query, and you should see the results coming soon. It's a function of the size of your data set and the sort of patterns that you're giving in. 21 results, and I have properties like year and the name. So that, in a sense, shows you the power of using Neptune queries while leveraging the text index of Elasticsearch. Let me go back to the slides. And talk about another key interesting features that our customers have asked. We are happy to announce the availability of a Neptune Workbench. Neptune Workbench is an in-console query experience. Today, customers typically have to set up an EC2 instance or expose their VPC endpoint and then query their Sparkle or Gremlin queries. With the notebook, which is essentially a Jupyter notebook, you can get started in a matter of seconds. You can point your cluster from the console. There is a section for notebooks. You can create one or more notebooks for your Neptune cluster, and all you do is say open notebook, and instantly you have a query editor that's available to write your Sparkle or Gremlin queries. This will be available soon, very soon. And why don't we actually look at a demo of how how Neptune Workbench works in the latest console. Let me go back to my demo machine and notice that on your left-hand side, you have notebooks as a first-class entity, right? I have a few pre-created notebooks, but the way you get started for your existing clusters is to just click on this Create Notebook button. And you can choose your cluster, give it a description, a name, and an IAM role for access. And then the notebook gets ready. I believe it takes less than a couple of minutes to just spin up a notebook. And once your notebook is ready, all you have to do is select that notebook and click on Open Notebook. And all it's going to do is it's going to redirect you into the Jupyter Notebook instance, and you have option of navigating into the Neptune folder. And there are a bunch of samples that we ship out of the box. In fact, the one that you saw me doing the Elasticsearch was also a notebook that I've saved in the same instance. A good example here is Getting Started Notebook with Jupyter. Remember the percentage status that I showed earlier? It's actually a command of the notebook. And all it does is it lets you query your status endpoint and gives you the result. And there are a lot more commands. You can use the, if you're familiar with Jupyter Notebooks, you can use a percentage magic and see all of the magic keywords, how you say this is a Sparkle query, Gremlin query, all of that is supported. And there are examples that walk you through both Sparkle and Gremlin in these sample notebooks. Let me go back to the deck. So like I called out, a lot of these features are based on feedback that's coming from you. And we really are thankful for all the feedback and look forward to you using Neptune with the latest version and giving us more feedback. And with that, I'll hand it back to Brad. Thank you.
Thanks. So we really want to hear from you. As you're building graph applications, tell us what your challenges are. Tell us what you'd like to see. Tell us services that you'd like to integrate with. And I'm going to flip through very briefly some resources that we have for you to learn more. And then I think we'll have some time for questions as well. So just to give you some context, so we have documentation. This includes not just using the service, but things like I talked about, the graph data model, pieces, documentation about the Elasticsearch integration, other pieces about different services, querying using Sparkle or Gremlin. So these resources are available. We have a set of Jupyter Notebooks also published as blog posts. These are now, will be available in the Workbench. And these can be a great way to get started. There's resources for learning Gremlin. Kelvin's book that I mentioned at the beginning is right here. It's available on GitHub under Apache 2 license. It's a great place to get started. It's continuously updated. There's also resources if you want to learn RDF and Sparkle. A couple of different links here that are useful. We have a reference architecture for graph databases on AWS that's available on GitHub. It covers things like integrating Neptune with Lambda. How do I use Kinesis streams with Neptune? So lots of useful things to think about. How do I think about my graph data model? And we also have a collection of different samples that are available through GitHub, blog posts, and other resources. We try and collect all of these on a developer resources page so you can access, if you ever want to go back to a reInvent video or a documentation, you have a single place to do that. And we also offer different kinds of training and certifications through some of the larger AWS programs. And so with that, I want to thank you very much for taking the time to join us here with Neptune. And I would invite you in the time that we have left, if you have any questions, feel free to come up to the microphone and ask them to any of us here on the stage. And we'll also be around afterwards for a few minutes if people want to ask questions independently.
Hi.
Hey.
I'm curious what it is about Neptune that warrants close integration with Jupyter notebooks that, say, other AWS databases don't choose to do.
What it really is about trying to minimize the time to access the graph and get started with a graph database. I think in general, a lot more developers are familiar with a relational database or a document store than they are with a graph database. And so we started off, we saw that customers liked the Jupyter notebooks that were provided by SageMaker. And we started this sort of series of blog post examples, and we got really positive feedback. And so when we were looking to shorten the time to access your graph, we thought that the Jupyter notebooks was a very convenient way to do that. But by no means is there an inherent coupling between the Jupyter notebooks and graph. But there are lots of graph and ML use cases, so it's a nice feature from that perspective.
Thanks.
Sure.
So, hi. So we've seen in RDS, for example, we started with instances, and we moved to serverless. In DynamoDB as well, we started with provisioning units. We moved as well to serverless. Is that a serverless an option in the roadmap of Neptune?
So we do not have serverless today, but it is something that is frequently requested by customers, and we, of course, work backwards from customers.
Yeah, thanks.
Hi, thank you. So one of the challenges that I've seen with adopting Neptune in my organization is that when we compare it to a relational database, because we have a microservices model, we have multi-tenant clusters in RDS, so we have multiple databases. And it appears that right now you only have a single graph in a Neptune cluster. So I'm wondering if you have any recommendations for ways to achieve similar multi-tenancy in a Neptune database, perhaps keeping the load off of developers to have to get queries right to filter the property graph properly and whatnot.
So you're absolutely right. Today, each Neptune cluster is a single database per se, so you don't have this kind of create database instance concept that you might have in MySQL, for example. We do have some customer requests for multi-tenancy, and something that we're looking at. It's a conjunction with serverless because it's also, there's different ways that you can make it easy for people to do development. Today, you do have some options in Gremlin, either in the way you use your graph model or to use the subgraph traversal strategy to restrict different clients to different parts of a graph, which might be an option. And then in the RDF space, you can choose to use the name graph feature as a container, which can do something that's similar to that. So we're definitely interested in the use case in general, though, for multi-tenancy.
All right, thank you.
A quick question on the notebook. So would it be possible to have the notebook running on the on-prem connecting to the instance that are running in the cloud?
Yeah, it's absolutely possible to do that. What you have to do is really you have to take whatever steps are appropriate within your deployment environment to make your Neptune instance that's sitting inside the Neptune VPC accessible from the host where you're running your Jupyter notebook. And so largely what the Workbench integration does is it provisions behind the scenes an EC2 host that's in the same VPC and has the IAM authentication configured for you. But it's absolutely possible to connect a SageMaker, a Jupyter notebook outside of SageMaker or otherwise to your Neptune cluster.
Perfect. Thank you.
Is Neptune query engine good with complex and/or not composition?
So, as Karthik mentioned, today Neptune is very much focused on interactive graph queries. That means something that's a parameterized lookup or parameterized traversal, somewhere between 1 and 3 hops. And part of the investments we're making from performance side is what we see is that as customers think more and more about their data as a graph and they're thinking about dealing with these interactive applications, they also then want to ask broader questions over them. So they want to ask more analytic, more OLAP type questions. So parts of the investments that we're making are to make Neptune also focus on those kinds of workloads too.
Is the Elasticsearch integration for querying going to support more than just the Lucene syntax, or will it also support the Elasticsearch query language?
You can pretty much pass through the Elasticsearch syntax directly. There's no filter that's applied to it. Okay. And the indices there's an API contract effectively between the properties that are created in the documents in the text index and then what Neptune is interpreting as basically node IDs and edge IDs. And so, but those can be queried directly, so there's no obfuscation per se. So if you use some of the tools that are provided to create your Elasticsearch index, you can also query those on the other side.
So Gremlin supports bidirectional edges from what I understand. So does Neptune also similarly support bidirectional edges?
Gremlin supports traversing a directional edge in both ways, but it doesn't support undirected edges.
I see. So on a
And you can have two edges, two directed edges. Of course.
Yeah, so I guess you could use something like Gremlin sessions to transactionally update both sides, though.
Yeah, so one of the features that was on Karthik's feature list was session support. Session supports allows you to effectively bind a transaction scope to a session, so you could certainly do that with it. There was also some things about the transaction semantics, so there's a couple of different things with, you can have write-write conflicts, so you need to make sure that you retry in those cases, but you absolutely can use sessions if you want to make an update in both directions.
And on the note of performance, so like let's say you have like a popular user in a social network, your incoming query could return millions of results. Do you have any options to like speed up those queries, like parallelize such queries?
Yeah, I mean, if you have effectively supernode kinds of scenarios, Neptune per se, if you're just traversing through the supernode and not having to materialize values, you'll see some performance impact, but it won't be significant. But at any time that you need to materialize those values in the supernode, then you're going to want to think about if there's ways you can filter it or other pieces just to reduce the amount of data that needs to be looked at to evaluate the query.
Yeah, like one thing we do when we model such data in Dynamo is just like shard those queries essentially into various partitions. So I was wondering if Neptune, like I guess you could probably model it the same way in Neptune as well.
Yeah, you can do some things with properties, on edges in those cases. There's a few other techniques that you have. I generally recommend people try and look at the model more holistically before they go to take those kind of steps, but those certainly are things that you can build.
And the final question, do you have performance numbers on the write throughput that you can take? Again, for like a super node kind of case, if some node gets popular.
Yeah, so the write throughput isn't affected by the density, by link density. Write throughput tends to be more of a function of the number of CPU cores that are available in the instance on it. And we don't have published numbers, but in general, the throughput that you can expect from the largest instances that we support today, which are the R512XL instances, is a throughput of somewhere between 60 and 80,000 nodes, edges, and properties per second on the property graph side, and a little bit north of 100,000 triples a second on the RDF side. And that's due to some differences in the constraint checking between the property graph and RDF models.
I guess that's helpful because, I guess if I map it to something like Dynamo, a single partition would have a max throughput it could handle. But here, I guess you're saying if on a single node you keep adding edges, that won't really run into similar issues. Is that
right? The fundamental architectures of Dynamo and Neptune are very, very different.
Got it. Okay.
So.
Yeah, thanks.
So on the subject, predicate, object, on the object, can I store multiple properties on it?
Yeah, absolutely.
Yeah.
Absolutely. So if you think about the airlines example that we showed, you had Seattle, which was the airport, that was a subject. Then you had the code, which was the IATA code, that was one property. You would have another line, Seattle, the city, some nickname pieces. So you're just, the way the data is being laid out, it would actually just be another row in that table.
Oh, so it is a different, essentially a different relationship. I'd have stored it as separate relationships, each of them. With respect to the Elasticsearch, what's the use case there? What's the general typical usage there? Do I do a query of the Elasticsearch, get keyword search of all my nodes, and then I traverse them? Is that the purpose?
There's a bunch of different use cases there. Just briefly, sometimes it's I want to start really broadly with a text search and then narrow down. And other times it's I want to have a graph pattern traversal, and then there's certain things I want to filter with more of a regex than supported. Remember that neither Gremlin nor Sparkle support a full regex capability as part of the language. So if you want to do those kinds of string operations inside of a graph traversal, you need to have something else there.
Same thing with maybe geospatial.
You can also use the geospatial. That's another use case within Elasticsearch.
But not in
It's not in database. It would be a federated query to Elasticsearch.
Thanks.
Hi. So in the next 18 months or so, would you expect that if you're looking to go multi-region, that the streaming method that you guys outlined is pretty much what we'd expect, and we wouldn't expect that all of a sudden now Neptune supports multi-region? Or is it on the road?
So we do have, as part of the enterprise features thread, we do have multi-region support on the roadmap. Very, very soon we'll be supporting cross-region snapshots. So you can take a snapshot from one region and make it available in another. And we have some other plans for different kinds of multi-region support early next year.
Yeah.
But Streams is a mechanism that you can use to do that today.
Right. Insofar as your Jupyter Notebook, it seemed as though you had said earlier that the Jupyter Notebook is inside the same VPC. So I'm wondering whether it therefore might have access to other things I deployed on that VPC that I might not want it to. So like that's more of an admin function or an ad hoc query function, and I'm worried about my other resources that I have on the same VPC.
Yeah, so by default, my understanding, correct me if I go off track here, is that the security policy associated with the EC2 instance on the Jupyter Notebook is restricted to just the network interface that Neptune's providing, as well, and then in the VPC. So it's not.
So if you wanted to get fancier, use your own notebook to get fancier.
Right. And you can also change the security group settings for that notebook to yourself, too, if you want it. Typically, we see people wanting to make it less restrictive, but you can also change it.
Yeah, until they talk to me, and then.
Right. Right. Sure.
And then the last question is, on the indexes that get built, is there a functionality for particularly, let's say, a large property that's only really output payload, that there's no value to have that payload be part of the starting point of an index traversal, just to have it ride along? Or will I always have that type of stuff off graph?
We didn't talk about it, but we actually use a dictionary compression inside of the index. So the actual values that you see are not stored as values, but they're rather stored as dictionary identifiers.
But they'd still be in the index?
They're not in the index.
OK. Thank you very much.
Yeah.
This may be a newbie question, but would there be an opportunity to or a possibility of using GraphQL to query the database?
Yeah, so one of the unfortunate things about GraphQL is that the name is graph, but it's not exactly a graph query.
Or just the parameters.
So we do see a lot of use cases for both exposing your graph data with a GraphQL view, and then also in the same way that people want to federate to other Sparkle endpoints or federate to Elasticsearch, federate to a GraphQL piece. So that's something that we're looking at from a product perspective. We'd be very interested in your use cases for it. So we have 1 minute and 56 seconds left before we get.
This is one more newbie question. I have all the existing applications which are all using the RDSS, traditional, and then DynamoDBs and so on. And if the use cases are more around, okay, Graph is a perfect fit for it, how do you see all my existing data getting into the Graph database? Do you think DMS at some point is going to bring in some of that?
Yeah, so we see customers do it in different ways. Last year at reInvent, Nike talked about how they were moving their social graph from Cassandra to Neptune. That's now in production. In that case, they did an export and a migration piece. We've seen other customers do different kinds of backfill type mechanisms to do the data migration. We are certainly looking at supporting Graph as a destination within the database migration service, and that in the future will likely be an option for you.
Thank you.
Sure.
So maybe I missed it in the lecture. I didn't quite understand if Neptune indexes all properties on the edge or just the key property or something.
Neptune indexes all the properties, of course, across the 3 indexes that I talked about.
Thank you.
37 seconds. Last chance. In the back beat you, and then see if you can repeat, either move the microphone or say it very loudly so others can hear. Could you repeat the first one? Oh, so the first question, one was, do we plan to support Cypher? And the second question was, do we plan to support geospatial queries?
Shackle.
Oh, do we plan to support Shackle? OK. So we do have customer stories for shackle support. It's something that we're looking at for this year. We don't have a firm timeline for it. Geospatial support, you can do some things now with Elasticsearch, and we're looking at other use cases for things that would be more in database with it. And let me take the last one in the 23 seconds here.
I was just wondering, what is the mapping to Elasticsearch? Is it each JSON document is the subject, predicate, object is stored as a single document, or are you storing in the graph?
Yeah, so the question is, how is the data mapped in Elasticsearch into a document? And basically, the way that the examples that we've shown and provided work is that each of the nodes effectively is represented in the graph, or sorry, in the document, and then there's a particular way that we're formatting the properties and the property names that are fielded in that text search document to represent the properties and the edge relationships on it.
But only one?
But one document per node.
Per node and edge.
Correct. Good. Other questions? Thank you very much.
Thank you.